Alright, hello, this is Post Logan. While I was editing this, I realized that my question A was just completely wrong. So I'm just gonna redo it. After this, you're gonna see that the answer is wrong. The answer should not be 1. Um, the answer should be 0. And if you're keen, actually, you would not see the clip. So initially, let's try this again. Log of A, since base is C, we'll just assume C is 10. So log A plus log 1 over A equals, let's just say this is some x. Let's raise this to the 10. So then it should be 10 to the log base 10 should cancel. So it should be, and then because, actually, let me write out this stuff. 10 to the log 10 of A. And then since it's plus in the exponent, we could also just multiply it. So 10 to the log base 10 of 1 over A equals 10 to the x. These cancel. So we get A times 1 over A equals 10 to the x. This should just be 1. So 10 to the x equals 1. Then x has to be equal to 0. So that's the actual answer to the question. You're going to see when I do question B later that my answer is 1 and the working out is different. And you can probably see why it's different and why it doesn't work, but just ignore it. So on to question B. P plus PM plus PM squared plus PM. And we can immediately see that this is a geometric sequence because we're multiplying by M every single time. Now, the way we like to do this is called a sum or a sequence, or using sigma notation. And here we would do the sigma from, let's just say, I don't know, let's just give a random variable n equals 0 to w, right? That's that value right there. So here we're gonna continue with our equation. So p m to the n. Now, what is I don't know if sigma was introduced yet, but basically think about it as like a repeat loop. So this, you would basically do this equation. So if n equals 1, n equals 0. So this would be PMN. So that's just m to the 0 is just 1, so it's just p. And then we would repeat it, but n is increased by 1, and so if n is 1, that's just PM. And then this increased by 2, which is 2, so that's P2. And it continues until n approaches W, which is, in this equation, PM. I have this line covering this right now. To the W. Right? Because what happens is we keep adding and adding until n goes to W, but we don't know what W is. But that's what sigma notation is. So, is there a Y? Oh, I see. Sorry, I'm blind. Collinear, I'm going to write that also on the side. But I'm going to draw this real quick. I'm going to make this a triangle. So I'm gonna redraw this shape a little bit, so we know this is also Y. We know this is also N, because they're squares. We know this is M. And we could say this is some angle theta. Okay. Because they're collinear, we know that all of these angles should be theta. And here, we're trying to find, in this value, I think we're going to try to find this value. I'm going to highlight this and shade it in. Because then we can, if we know this angle, which we also need to find, now that I think about it, do we need that angle? Maybe we'll try with the angle. So here, to find that, that's just n minus y. So this line is just n minus y. And to find y, we need to do tangent. So this is n minus y. That's the opposite, and we know tan. We're going to do tan theta equals opposite over adjacent. So that's the opposite. The adjacent is y. Tan theta equals. This is cancels. Does not cancel because it's a subtraction, so you cannot do that. But that's what that is. So this means that inverse tan of n minus y over y equals theta. Now here we know that theta is here, which is y minus m over m, and I just realized that I don't need this inverse tan stuff, because this is the nice part. We see that tan is the same here, so we could do a little bit of a systems. N minus y over y equals y minus m over m. So here we can multiply y squared minus ym equals mn minus ym. Here we can add ym. And then we can root it. Now we would put a plus or minus, but I'm pretty sure these are positive measurements. So now if you notice anything similar, this is a geometric sequence, and we can tell because the addition is that the slope is collinear. And if you remember this formula, this is the same formula as geometric mean. So here we just proved that it's that the formula of how to get geometric mean through this. So yeah, I think that's really cool. Next problem. Okay. Moving on to question 45. Show that y equals to cosine 2x can be rewritten in the equivalent form. Y equals a sine of x plus b. Therefore, confirming that the cosine curve is sinusoidal. The definition of sinusoidal is on the right. So here we learned that cosine of x is equal to sine of x plus pi over 2. Yep. So, cosine 2 of x should equal sine 2 of x plus pi over 2. So, this is that. This should equal 3 cosine of 2x, which is sine of 2x plus pi over 2. And that should be your answer. (45) is pretty simple if you just remember what we did on a previous problem. With this, I'm going to square this. It's really important to memorize. The cosine to sine conversion. So, just to make sure that I'm right, I'm going to graph my answer. Okay, so here I can immediately tell it's a story problem. So here I'm going to draw. There are 2 boxes. The red box contains 4 marbles. And one. God, how am I gonna? One blue marble. I'm gonna symbolize blue with that. The blue box contains 5 blue marbles and 3 red marbles. The following experiment is done 100 times. Okay. A marble is randomly drawn from one of the boxes. Its color is recorded and then replaced in the same box. The first drawing is from the red box, but each is determined by the color of the marble most recently drawn. If it is red, the next drawing comes from the red box. If it's blue, the next drawing comes from the blue box. What is the probability that the first marble is red? So, this is just a 1 in 5. You can see there's just 1. 4 and 5. I thought that was a red marble for a second. I actually could have read a key. There's a 4 in 5 chance for the first marble to be red. Because there's 4. Yeah, I think that's pretty self-explanatory. So for A, 4 in 5, which equals 80%. The first marble is blue. The second marble is red. Okay, so here it's a 1 in 5. So here I'm just going to write this down. And it says there has to be a second probability. We have to multiply it by the probability of the second marble being red, which is a 5 and 8 chance. And this would equal 5 over 40. It's 1 over 8. Which should be 12.5%. Just multiplying the probabilities when you're trying to find 2. The second marble is red. So we know already that the first has to be blue, right, to get to the second box. So it's 1 over 5. Or the probability could also be if it pulls a red and then a blue. So I'm going to write both probabilities out here. So I'm going to write B for blue and R for red. So there are two probabilities that could get the result. If we get a blue marble first, so that's 1 over 5, we then have to multiply it by the chance of getting a red marble here, which is 5 over, blue marble, which is 3 over 8. So that's the chance if you picked a blue marble first to get a blue marble second. Again, here and then here. For this opportunity, you have to first find out what the chance of is pulling a red marble, stay in the red box, and then pull a blue marble. And of course, if we stay in the red box, the chance of getting another blue marble is 1 over 5. So if we and then we sum these up because there are two probabilities that we can get, not equally, but two probabilities that we add up because those are the two possible probabilities. 1/5 times 3/8 is 3 over 40. 4/5 times 1/5 is 4 over 25. And I'm just going to plug this into a calculator real quick. 23.5